Okay, in the last video we found a way to graph the sine wave and the cosine wave. Now in this video we're going to graph tangent and maybe cosecant. So to start with tangent, let's see. We have our setup here, we have the 5 key points we want to graph. So we'll draw our xy coordinate system and let's see. Tangent is opposite over adjacent, so it's y over x in terms of the unit circle. So at 0, we're at the point 1, 0. Which means opposite y is 0, x is 1. We get 0 over 1, which is 0. Pi over 2, we're at the top of the circle, which is a point 0, 1. So we get 1 over 0, which is undefined. At pi, we're on the left of the circle, negative 1, 0. Opposite over adjacent, y over x is 0 over negative 1, which is 0. 3 pi over 2, that's the bottom of the circle. At the bottom of the circle, we're at the point 0, negative 1. Y over x is negative 1 over 0, which is undefined again. Still can't divide by 0. At 2 pi, we're back where we started at the point 1, 0. Y over x is 0 over 1, which is 0. Which isn't giving me very much information as far as my graph goes. But let's see. When x is 0, f of x is 0. At pi over 2, we get undefined. All of you remember from 171 from graphing rational functions, if it's undefined, you draw a vertical asymptote. At pi, we get 0 again. 3 pi over 2, another undefined, another vertical asymptote. And then at 2 pi, we're back to 0. That doesn't necessarily tell me a lot about my graph, but you guys can rely on your knowledge of rational functions, vertical asymptotes, and the unit circle, and we should be able to figure this graph out. Let's see, the rule for a vertical asymptote is you either have to approach infinity or negative infinity around the asymptote. We also know there's no other zeros for the tangent function. The only place it's 0 is where y is 0, which is at either the right or the left-hand endpoints of the unit circle. So if I can figure out if the value of tangent is positive or negative between 0 and pi over 2. If I'm above the axis, if I'm positive, then I have to go vertical. If I'm below the axis, negative, then I have to go vertical down here. So pick an arbitrary angle. Go with pi over 4. That's a 90-degree angle, so go with pi over 4, 45 degrees. At pi over 4, tangent is root 2 over 2 over root 2 over 2. All of you know this from the unit circle. That's 1. So at pi over 4, we get 1. And now I'm good. If it's positive here, I can't go back down because that would give me another 0 that I don't have, which means I have to go up and approach the asymptote this way. Well, now, what about this side of the asymptote? Same idea. If that's pi over 2 and that's pi, all I really care about is if tangent is positive or negative, because that will tell me if I'm down here or up here. So pick an angle between pi over 2 and pi, or think about your unit circle. Pi over 2 is the top of the circle, pi is the left of the circle, so we're in the second quadrant, right over here on our unit circle. In the second quadrant, x is negative, y is positive, so tangent, y over x, is negative, positive over negative. Which means tangent is negative down here somewhere, which means I have to go this way. Over here, same thing. This is pi right here. That's 3 pi over 2. What's the sign of tangent between pi and 3 pi over 2? Pi is on the right, or on the left from your perspective. 3 pi over 2 is at the bottom, so we're over here in the unit circle, third quadrant. In the third quadrant, x is negative and y is negative. Tangent's y over x, negative over negative. Tangent's positive, which means your tangent value is here, which means I go up. And now, if you're seeing the pattern, tangent's more than likely going to be down here for this part, but check it. Let's see, if that's 3 pi over 2 and this is 2 pi, well, 3 pi over 2 is the bottom of the unit circle, 2 pi is the right of the unit circle. That means we're on this part right here, fourth quadrant. Let's see, x is positive, y is negative. Tangent is y over x, negative over positive, which is negative. So tangent's negative here, And again, I go down. And now we can kind of see the pattern of what's going on. This is going to go up like this. Then there'll be another vertical asymptote, and it will keep repeating. Over here, same thing. It'll go down. There'll be a vertical asymptote, and it will keep repeating over and over and over again. As far as it goes, we care about our properties, so let's see. For sine and cosine, we had an amplitude, we had a period, and we wanted to know if it was even or odd. Well, let's see, the amplitude, in this case, the graph goes all the way up to infinity and down to negative infinity. So the amplitude, there really isn't one beyond saying that it's infinite, because infinity divided by 2 is still infinity. The period, this one is a little bit different. How often does the wave repeat? Well, in this case, there's two ways to see it. If I start at 0, 0, like I did for sine and cosine, the graph goes up here, so there's no repetition. Then it jumps down here, no repetition. You go up, and once you hit 0, then you'll start repeating, going up again, which means this is actually my tangent period. It goes up, and it starts down here and goes up again. That's 0 to pi, so the period is pi. That can actually be a little bit hard to see, so a lot of times when we graph this, we'll graph this part of the wave just so we can see the continuous connection right there. And let's see, if that's pi over 2, this is negative pi over 2. And we see the period is pi again. It doesn't really matter how you graph it, whether you go 0 to pi, or negative pi over 2 to pi over 2. Normally when I do it, and when I'm doing it on here, I'll do it this way. It doesn't matter. As far as even and odd, let's see. That is symmetry with respect to the y-axis or the origin. Well, if we look right here, if I take this part and flip it, that doesn't work. There's nothing here, so it's clearly not symmetric with the y-axis, so it can't be even. If I take this, flip it, and flip it, I do get that. Which means it is symmetric with the origin, which means it's odd. And there we go. So now we have our basic trig functions, sine, cosine, and tangent. Now we want to look at the reciprocal ones. I am only going to do one of these. I actually gave it to you as homework to mess around with these, so you guys can see how they work. But there's a nice little trick for these things. We'll go with cosecant, because cosecant's reciprocal of sine, and that's where we started. So let's see, we'll have x and f of x. We'll do our basic functions again. Let's see, or basic values, x is 0, pi over 2, pi, 3 pi over 2, and 2 pi, and then we'll get our repetition. And let's see, just keep in mind, cosecant is 1 all over sine of x. So we know the sine values, do the reciprocal of those, and we'll get the cosecant values. So at 0, sine of 0 is 0. So I get 1 over 0, which is undefined. Good, more vertical asymptotes. At pi over 2, sine of pi over 2 is 1. So I get 1 over 1, which is 1. At pi, sine of pi is 0. I get undefined again. Seems to be a lot like a tangent function. At pi over 2, the bottom of the circle, sine is negative 1. I get 1 over negative 1, which is negative 1. And then at 2 pi, I'm back where I started, 1 over 0, undefined. So yes, it mirrors the tangent function a lot. Plot our graph, plot the points we have, and see what we can do. Well, let's see, it's undefined at 0. This vertical asymptote is hard to see, but it is there. At pi over 2, we'll say it's right here, we get 1. At pi, we get undefined again. 3 pi over 2, we get negative 1. And then at 2 pi, we get undefined again. Well, as far as graphing this goes, we can actually kind of rely on the knowledge we already have. We know from the tangent graph we just did that these asymptotes either approach infinity or negative infinity. And since these graphs are continuous within these intervals, I know they're not continuous through the asymptotes, they're continuous on these intervals. If we just figure out what's happening at one or two other points, then we should be able to sketch everything else. So let's see. Are there any zeros on the cosecant function? We don't have any zeros graphed. Are there any zeros? Well, if you think about it, cosecant is 1 over sine. Can that ever equal 0? No, it's 1 over sine. The only way it could be 0 is if the numerator is 0, and the numerator is never 0, it's 1. Which means I never get a 0, so I don't have to worry about that. And if we remember from our definition of reciprocal functions, the minimum value of cosecant is actually the 1 right here, in this quadrant right here. Down here, the maximum is -1. For our domain, the domains kind of go up and down for those functions. We went over this before with our reciprocal functions. Alternatively, pick some other point. Let's see, if that's 0 and that's pi over 2, then take pi over 4, which would be right in between those two. At pi over 4, sine is root 2 over 2, which means 1 over sine is equal to 1 over root 2 over 2, which is 2 all over root 2. Can't have a radical in denominator, so multiply by root 2 on top and bottom, and you get 2 root 2 over 2, which is just root 2. Throw it into your calculator. Root 2 is about 1.4. So at pi over 4, in between 0 and pi over 2, we get 1.4, like right there. And now I can see what's going on. I'm just going to go up like this. I am not going to take the time, because this video will end up being too long, but if this is pi over 2, and that's pi, pick something between pi over 2 and pi. Find the sine. You can actually use 3 pi over 4, because the sine is a y value, and it's the same sine value as pi over 4, which will give me positive 1.4 again up here, and the graph does that. Over in this quadrant, do the same thing. Look at 5 pi over 4 and 7 pi over 4. You get the same 1.4 value for sine, but now you're in the third and fourth quadrant, which means sine is negative, which means you get negative 1.4 here and here, and your graph looks like that. And now, obviously, this is going to repeat, so over here it'll do the same thing, and over here it'll do the same thing. And it'll just keep on repeating. As far as it goes, we need to know our amplitude, our period, and whether it's even or odd. So really quickly, so I don't run out of time. Amplitude, well, much like tangent, this shoots off to infinity and negative infinity, so the amplitude is infinite. The period, well, I'm above the axis and below the axis, and then I'm back above it. So this is my wave right here, 0 to 2 pi. So the period is 2 pi, just like sine. Even and odd, well, sine was odd, symmetric about the origin. Cosecant, take this, flip it, you get that. This one is odd. It makes sense. A function and its reciprocal have the same even or odd properties. The last thing really quickly, a trick you can use to graph these things, and it will help you as you graph maybe cotangent or secant yourself. Cosecant is reciprocal of sine. Graph a sine wave. You would start at 0, go up to 1, back through 0, down to -1, up to 0. And now you can see where the reciprocal comes from. Anywhere sine is 0, its reciprocal is undefined. And then they meet when sine is at its maximum or minimum, 1 or -1. So to graph your secant graph, just graph your cosine wave and kind of connect the dots that way. In the next video, we're going to look at transformations of these and see what we can do with them.